All right. Good evening once again to you guys, and I do believe you guys are okay. So, in today's class, we'll look at motion. I'm sure you can see a car which is moving on the screen. You can see, I don't know where it is going, but it's just in motion. So in physics, we need to understand certain types of motion that every object can undergo. Okay, so we have different types of motions. But in today's class, we are just going to look at the uniformly accelerated motion. So in today's class, we are just going to look at the uniformly accelerated motion. So the uniformly accelerated motion is also referred to as linear motion. Okay, so when you see a title which is saying linear motion, or a title which is saying uniformly accelerated motion, or motion in one dimension, then we are simply talking about the same thing. So please make sure that you follow up, make sure that you ask questions where you are not clear, because this is forming the basics of projectile motion. This will also help us to understand the Newton laws of motions as we go further. Okay, so we need to understand the quantities of motions. Okay, they're what we are calling the quantities of motion. So everything that is undergoing a certain movement, any object that is moving from one particular region to another region, it normally undergo a certain type of motion. Now, this motion is simply having what we are calling the quantities. Okay, so any motion involves three concepts. Every motion involves three concepts. The first concept is displacement. I'm pretty sure when we were doing vectors, I had to touch a bit on what displacement is. When you talk of displacement is simply a what? A vector quantity. And it being a vector quantity, it simply means that it has direction and magnitude. It has direction and also magnitude. The first, the second quantity which every motion has is velocity. The first thing was displacement. Then the other thing which everything which is in motion has is velocity. Then the last one is acceleration. So basically, there are three concepts that are involved when you are talking about what? Motion. And these concepts are displacement, velocity, and acceleration. You need to understand that all of them are simply vector quantities. All of them are simply what? Vector quantities. So everything here is just a vector quantity. And them being a vector quantity, that simply means that they have what? They have direction, and they also have what? The magnitude. They have direction and they also have a magnitude. Okay, so with that being said, we need to understand that these concepts can be used to study objects in motion. So you can talk about something that has been thrown. For example, you throw a stone. Okay, that stone will be in motion. Let's say you yourself, you are running, you are in motion. You can talk about a car which is moving, it is in motion. So these concepts, these three concepts, they normally help us to study any object that is in what? That is in motion. So, ladies and gentlemen, before I move further, do we have any question on what has just been explained? Okay, so looking at the silence, that simply means that we don't have a question. So I mentioned that we have three quantities that normally determine the motion of an object. We have three quantities or concepts that help us to understand the movement of an object. The first one was displacement. The second one was acceleration, and the other one was velocity. So let's quickly look at what displacement is. Okay, you need to understand that displacement is a vector quantity. It is a little bit confused with distance, but there is a difference between distance and displacement. Displacement is a vector quantity. That means that it has direction and magnitude. But when you talk of displacement, is a vector quantity. Displacement is a vector quantity. And when you talk of distance, it is a what? It is a scalar quantity. Okay, so let's move on and look at this displacement. So one thing that you need to understand when you talk about displacement is that displacement is a change of position in time. The change in position in time. So when one object moves from one position to another, that's what we are calling displacement. But that displacement, it has to be within a specific what? Within a specific time. So displacement is a change in what? In position within time. The other thing that we need to understand is that displacement is being written using the formula change in position. So x is just simply standing for what? Displacement. So displacement, final displacement, this is talking about final displacement, is equal to final displacement minus the initial displacement. So this is the resultant displacement. So this one is talking about the resultant displacement or the net displacement. It can be said to be resultant. In some books you can say that is resultant. In other books that can be said as the net displacement. Okay, so the net displacement is equal to final displacement with respect to time minus the initial displacement. Okay, so for example, let's say we have this movement. Okay, let's say an object first moves 2.5 meters. That's the first movement. And then the second movement, it is -2 meters. So these signs you are looking at, these signs are just telling us the direction. So if this object moves 2.5 meters this side, okay, and later on, this is 2.5, and later on it moves -2, which is somewhere there, which is -2 meters, and that is positive 2.5 meters. So the resultant or the resultant displacement or the final displacement is simply equal to what? Is simply equal to positive 2.5 meters minus -2. Okay, so that one has to be positive there, and then there has to be negative, and this has to just be 0.5. So the resultant will simply be what? 2.5 minus 2 meters, and your answer will be what? 0.5 meters. The reason why we have put 0.5 meters is that this first movement was moving toward the right, and the other one was moving toward the left. So that's how easily you can work out the final displacement. But if you talk of distance is where you just add those two guys. Okay, so in this case, final, this F in the formula is just simply talking about the final distance, and then that one is just standing for initial. Okay, the other thing that you need to understand is that displacement is a vector quantity. Okay, displacement is a vector quantity. If you observe, there are some signs that I have added to this guy. So it being a vector quantity, this simply means that it has one direction, then two, it has what? It has the magnitude, which is just the size. So these are the two characteristics of what? Of displacement. It is a vector quantity. Okay, so same applies with this object. If this object moves -3 meters, meaning it goes this side 3, and then it goes this is 3, and then it goes the other side, which is 1. Let's say it goes like that, which is positive 1 meter, and that one is negative that. So if you look at the final velocity, you just simply put there a minus, there it will be positive, and there it will be minus, and your answer will simply be what? 2 meters in the negative direction. Why? Because this guy is simply the what? Is simply a vector quantity. So take note of that. When I say notes, I'll make sure that I edit these guys I had to put because of typing. Okay, so with that being said, this is the reason why I said displacement is a vector quantity such that it has magnitude. So when you talk of magnitude, this is the size. Okay, this is the size, and then this size, it normally has the units and the number. The magnitude has the what? The units and what? And the number. Okay, so the number we are talking about is this number in front, and the unit, it's just the meters. So please, this displacement, it has been explained more when we are discussing what? When we are discussing vectors. Do we have any questions at this particular moment so that I move on? Any question? Okay, since we don't have a question, you need to understand that the units of displacement are just what? Meters. So meters are the SI units of displacement. Meters are just the SI units of displacement. So where you are finding the displacement, you need to put what? Meters. I can see Florence with a hand. Florence, what's your question?
My network was tripping, so I have missed a bit. I don't know what were we finding here. And the formula for displacement is the one that is on top there.
Yes. So here, what I was just giving here was how you can use the formula, and I was emphasizing on the fact that when you talk of displacement, it is a vector quantity. So if an object moved, first it moves 2.5 meters right, like the one I've drawn, then later on it moved negative 2.0 meters. So the final displacement, you can find it by saying final displacement is equal to negative 2.0 meters minus 2 plus 2.5 meters, and this will give you 0.5 meters. The reason why we are doing that is because these are in opposite direction. So the same thing can be said when you talk about the guy down there. Is that okay, Florence?
Alright, thank you.
You're welcome. Okay, so we can move on. I don't know if there is any question. Feel free to ask. Okay, we can move. So after learning the part for for displacement, it's very important for us to have interest in knowing what average speed is. Okay, yeah, we know what displacement is, and we said, okay, displacement is a vector quantity, but we can also talk about the average speed before we talk about the velocity of a car. So when you talk of average speed is simply found using the formula which I have highlighted here. So S is standing for speed, so this one is standing for speed, and then this one is the total distance. Okay, so average speed is just equal to total distance over a change in time. So the part which is like that, t, is just simply mini change in time. So when you talk of the average speed is just found using the what, total distance over over time. And one thing that you need to understand when you talk of the average speed is that its SI units are meters per second. Its SI units are just what, meters per second. Then this one has no direction involved. You don't have to involve any single direction. You don't have to involve any single direction. Okay, so that's for the average. That's for the average speed. Then it's not having any direction. That simply means that it's a scalar quantity. So average speed is a scalar quantity such that it has no direction. It has no direction. So this guy, it only has the what, the size. It only has a size. It only has a size, no direction. So you need to understand that when you talk of the average speed, for example, in a case whereby a car moves, let's say the first one, it moves 6 meters, and then it also moves another 6 meters. So what you're going to do is you're just going to add the summation. Okay, you're just going to find the summation of the 2 6 meters. So let's say a certain car, I'm going to put that. Okay, I think that's again that. Okay, I'm going to play that again. I'm going to play that again. So look, the first thing that this car has, this object has moved, is that it has moved one, it has gone up. I hope you guys have observed that it has gone up 6 meters. Okay, let's say the first one, it moves 6 meters. Again, it goes back 6 meters. I'm repeating that. First, it does what? The first time, the first step it has done, it has moved 6 meters going up. Okay, so that's 6 meters. It is the first 6 meters that we are having. Then the time which it has taken for it to reach these 6 meters is such that it has moved 4 meters to go up, 4 seconds to go up, and then when going back, it has moved 1 second. That's why we have gotten such an issue. Now, one other thing that you guys are supposed to understand is that after this guy has moved, there is also a part whereby it is going back. So this object is moving twice. It has gone up once, 3 meters, 6 meters, sorry, and then gone back 6 meters. So if you look at average speed, we are going to consider 6 plus 6. Why? Because it has no direction. Average speed, we are going to put 6 plus 6. Why? It has no direction. But for average velocity, it's going to be 6 minus 6, which is making it 0, because this object has moved in the opposite direction. So for speed, the direction doesn't matter, you just add them, okay? But for velocity, which is a vector quantity, the direction matters. That's why when it moves from here, which I can say point A, and goes to point B and come back, then the speed, let's say this was 6 meters, it's going to be 6, and then coming back 6. So meaning average speed, it will be the distance, it will be 6 plus 6. That's why you have 6 plus 6. The time, if you look at the time here, from the data here, you can find that the time which has been spent, okay, to move from one region to another, let's say this guy moved from here to there, it rested, and then it moved from there to there, and then it rested. Then from here to there, let's say it lasted 4 minutes, okay? Or we can put it from here to here, I think, yeah, according to this law. So from this particular point to that particular point, let's say it lasted for 4 minutes, okay? And then we have this particular distance, which it has not been shown because there was a 0 to 1 here, but this started from 1 to that. So if you observe, you can remove this one there, you remove it from 4, and it's going to give you 3. So if this car or this object utilized 3 seconds to move from here to there, 3 seconds from here to there, just from sketching there, just from looking at the graph, you can also say 4 minus 1, because it started from 1, okay? Since it started from 1, or you can just remove a 1 inch which has been covered already this side. So since started on 1, you can simply say 4 minus what? 1, and the total time which was utilized was 3 seconds. That's why I have said 4 minus 1 is equal to 3 seconds, because this object started from what? From 1. And then when you talk of the distance covered from this particular point to that particular point, it was 6 meters, and then this same object, it came back, okay? So first it went up like that, and then second it came back, okay? It went up and came back. So first it went and then it came back. Now when it went from there to there, it covered 6 meters. That's where the first 6 meters is. Then coming back, it also covered 6 meters. For the speed, we are going to add 6 plus 6. The time will still be 3 minutes plus 3 minutes. So 6 plus 6 is what? 12. 3 plus 3, it is 6. 12 divided by 3, it is 2 meters per second. Meter is coming from what? From the distance. Second is coming from time. Then if you talk of average velocity, because this one is a vector, okay? Remember, this guy is a what? Is a vector. It being a vector, you are going to consider the what? The direction. So when this object moved from point A to point B, it was moving in the positive direction. If you observe very well, this is how I have moved. When it is going up, this side is going also opposite direction. When going down, this object is going back in the negative direction. So because this is a vector quantity, you are going to say 6 minus 6. That's why you have a 0 there. 6 minus 6, because this is a what? This is the velocity, and velocity is a vector quantity. So this is what you are supposed to take note when you are looking at average speed. You don't have to worry the direction, you just have to make sure that you add them. But for velocity, you need to worry about the direction. Do you have any question on this particular point before I move on? Please raise your hand so that we move on. Itheo, do you have a question? Okay. Benzo, what's your question?
An explanation, sir. The network is really bad, so I wanted to ask if these things that you're highlighting in red, I don't know if they'll be there during the video or what, because the network is really breaking.
Okay, everything, whatever I'm saying will be in the video, and whatever I'm writing will also be in the video. So in case your network is bad, don't worry, the video will be what? Will be recorded and it will be posted on the channel. Is that okay, Benzo?
Yes, thank you very much.
Okay, all right. So after learning the average speed, we also need to look at the opposite side, okay, the other side of the coin, which is the average velocity. We know the average speed. Now we need to know what this average velocity is. Okay, so velocity on its own, it has two parts. There is uniform velocity and you also have the instantaneous velocity. So we are going to look at both of them as we discuss. So average velocity, take note of the direction. So when you talk of average velocity, you need to understand that you can find average velocity by using this formula, the change in displacement. Okay, remember, first we did displacement. Okay, this was the net displacement. This was the net displacement. So when you talk of velocity, you consider the what? The average displacement, the change in what? Displacement over what? Over time. Change in displacement over time. In short, when you talk of the average velocity, you are just looking at the slope of the distance time graph. Because if you look at this graph, this side it is what? It is time. And then this other side it is what? It is the distance. So when you are finding the average velocity, you are looking for the slope. Okay, let's say this particle, this is point A, okay, and then that one is point B. So when you are looking for the average velocity, you're going to start with the final minus the what? The initial. So point B will be your final, which is XF, and the point A will be your initial, which is what? Which is A. And then take note of the change in time. For example, in this case, the time which was taken was, first going there, it was 4 minutes, but it started from 1 second. From 4 seconds, it started at 1 second. That's why you have to say 4 minus 1, because it started only on 1 second and it reached 4 seconds. So when you talk of average velocity is the slope that you get when you are dealing with the distance time graph. We are going to look at the graph later. Then for you to find the average velocity, you need to know the change in displacement. Okay, the change in displacement. So because this guy is a vector quantity, okay, this guy is a vector quantity, you need to know the what? The direction. In as much as you solve, make sure that you consider the what? The direction. We'll look at that more. Now, like I have already said, the average velocity is the slope of the line segment between the endpoint on the graph. Is the slope, this guy here. You can see this pink guy here. That's what we are calling the what? The average velocity. It is the slope. When you talk of the slope, you are talking about the what? The gradient. When you talk about the slope, you're simply talking about the what? The gradient. It is the slope. Okay. Now, this slope is having displacement. This side is displacement, and then the other one, it is what? It is time. So, with that being known, since this side is displacement, that side it is time, you need to understand that the SI unit of average velocity is the same as that of speed, just that these ones, they have direction and they are vectors. So the SI unit, it is what? Meters per second. Meters is coming from length, okay, length, and this length is coming from what? Is coming from displacement, okay, displacement. And then second, it is simply what? It is simply time. So the SI unit of average velocity, it is just length over time, or meter over second. So like I've already stated, that's it. So average velocity, one other thing that you need to know is that it is a vector quantity. It is a vector quantity. That's why most questions you find an arrow on top. Okay, you find an arrow on top like that. So the arrows that you see, they are just telling you that it is a what? It is a vector. And this direction of a velocity, it depends on the direction of displacement. The direction of velocity depends on the direction of what? Of displacement, because we know that displacement is also a vector quantity. That's the reason why you need to put the signs like we did in the previous part. So if an object has moved, the way it has moved, okay, if it moves from point A to point B, the way it is moving there, so it has moved from point A to point B. Let me repeat that again. It has moved from point A to point B. So you need to consider the movement. You need to consider the movement. So since it has moved from point A to point B, this is in the positive direction like that. Okay? Now, this positive direction, it has again gone back towards the negative direction. So because it has gone up and back, the average velocity is what? Is 0, because it has moved in the opposite direction. Going up, then again it has gone down. Because velocity is a vector quantity, the average velocity of this guy is what? Is 0. I'm repeating that because the object has gone up and then it has gone down. So due to that fact, this guy is what? Is 0. The average velocity is 0, because the distance which the displacement it covered going up is the same displacement it has covered going down. Same applies with this side. If you look at this side, first it has gone toward the positive, which is 6 meters. You need to understand -3 to 3, there is 6 meters. Again, it has gone back to negative, which is another 6 meters. So the average velocity is just simply what? 0. Okay. Is there any question, ladies and gentlemen, on this particular point? Do we have any question before we move on? Any question? Chimuka, do you have a question? Chimuka? Okay, everything is clear. So we can move on and look at the graphical interpretation of velocity. the graphical interpretation of velocity. How can you interpret when you are given the information on a graph? So 1, velocity can be determined from a position time graph. Position time graph, or this position, it's this word position, can be replaced with the displacement time graph. The displacement time graph. Okay. Then from there, you need to understand that average velocity equals the slope of the line joining the initial and final positions or displacement. So ladies and gentlemen, what I'm teaching today is something that is mostly focused on the MCQ. And this is something that will help you to understand how you can solve. So when you miss out the points, the theory side, then the application will be very hard for you. So the velocity can be determined from the displacement time graph, and the average velocity equals the slope of the line joining the initial and final position or displacement. Now, another thing that you need to understand is velocity is a vector quantity. That simply means that you need to consider the signs and direction. Now, an object moving with a constant velocity will have a graph that is a straight line. Get that? An object moving with a constant velocity, meaning the pace at which this object is moving is the same, will have a what? A graph that is a straight line. That is how the graph will look like. That is how a graph will look like. Just a straight line, like that. This is the straight line. So when you have this side as your displacement, okay, when you have this side as your displacement and this side as your what? As your time. I'm sure you can see T there, you can see there M. So M is just simply telling you that this guy is the displacement. So the value, ladies and gentlemen, the value of the slope of this guy is simply the velocity of this object. So if this object moves from point A to point B, again it moves from point B to point A, the size of this slope is what you are considering to be what? The velocity. Remember, the time has to be the denominator. So this which you are seeing here is what we are now having the graph of an object with the constant velocity. Constant velocity. The velocity is not changing. It is constant. Now, there is also instantaneous velocity. Like in this case, if you look at how this object is moving, it is moving in such a way that time is approaching what? 0. Time is approaching 0. Time is approaching 0. Okay, so such a velocity is known as what? Instantaneous velocity. So in instantaneous velocity, the time normally approaches 0, but I'm not interested in that. All I'm interested in is explaining what a graph of a constant velocity looks like, and then also you knowing the value of the guys which are on the y-axis is the displacement and the x-axis is what? It's time. And remember, the displacement has to be in meters and then time has to be in seconds, so that you can have the SI unity, the standard which is accepted internationally. So ladies and gentlemen, do we have any questions on this particular part? Do we have any questions? Daonga, do you have any question? Daonga?
No, sir.
Alright, that's good. So these are basics. In the next class, I'm going to be solving. In the next class, I'll be solving. So as I'll be solving, I'm going to be using these same theories to apply to whatever I'll be solving. So make sure that you follow up. Okay. Now, instantaneous velocity, I've already explained it. I'm sure you guys have gotten my point when I was explaining instantaneous velocity. So when you talk of instantaneous velocity, it just simply means that at some given instant, the instantaneous velocity indicates what is happening at every point of time, such that you need to understand that this guy is a limiting process, whereby it depends on the slope of the tangent. If you look at this part here on part B here, there is a line which has been drawn. That line is a tangent. A tangent is a line touching the curve at one particular point. A tangent is a line that touches a curve at one particular point. So in an instantaneous velocity, you also need to understand that time is approaching 0. And in such a way, that's where calculus comes in. But for now, we are not interested in that. So this part there, you need to depend on the slope of the tangent. So the slope of the tangent is equivalent to the velocity. There, same applies there, and also same applies there. And remember, time approaches 0. That's why we have that formula. Lim, time is approaching 0. Or you can find it using calculus, whereby you say dx dt. Okay, dx dt. Dx is just simply saying the displacement side, dt is just talking about the time. I think that has already been explained. That formula I've explained. One, you also need to understand that instantaneous velocity is also a vector quantity. The dimensions, the unit is just meters per second. And then it is the slope of the tangent. All these I've explained it. So the instantaneous velocity of this particular guy at point B is equal to the slope of the tangent. There it's equal to the slope of the tangent. There it's equal to the slope of the tangent. So the velocity at this particular point, it is not the same as that. It also not the same as that. So that's what instantaneous velocity is and what you're supposed to know. Do we have any questions, ladies and gentlemen? Do you have any questions before I move on? So guys, these are basics. With time, we are going to start going in details bit by bit, especially in the next class. In the next class, we are going to have calculations. For this one, it's all about the theory part. But next one, it's all about calculations before we even start tackling what projectile motion. Okay, let's move on. Uniform velocity, I think I've already explained. So uniform velocity is the special case of constant velocity. Okay, then you need to understand that in this case, instantaneous velocity are always the same, or the instantaneous velocity will also equal the average velocity. In short, what we are just trying to say is the what, the velocity is just the same. There is no specific change. Okay, so in a case you have let's say velocity this side, and then you have time there, you can easily look for the final displacement, and this is the formula that you can look at. So this is the formula. In short, we are looking for the area here, so we are looking for the area there. So the area there can just be the same as the distance covered. I'll explain more on this when we do the calculations. So from this formula which we had, we can have that particular formula just by making this one a subject of the formula. So let's say we have Vx, okay, is equal to then xf minus xi over change in time. You cross multiply, you are going to have Vx change in time is equal to xf minus xi. This one goes to the other side. Xf is equal to xi plus Vx and then change in time. So this formula and that formula are just relatable, and you can derive this one from that one. So that's what we can talk about on this particular part, but I'm going to explain more when we do the calculations. When we do the calculations, that's when I'll explain more on how to apply these two formulas and how best you can do it. Okay, let's quickly look at average acceleration. I don't know if there is any question. Please, if you have a question, feel free to ask before I do average acceleration, and then next time we'll meet, I'll just be solving questions so that you know how to apply. Okay, who is this one? Caleb, do you have a question? Caleb, do you have a question? You don't have. Okay, all right. Okay, we can move on and look at something else. So average acceleration, this is just the changing in velocity whereby there is a change in velocity. So change in velocity whereby this change in velocity is in relationship with time. So such is what we call the average acceleration. Yeah, I think I've already explained where I've said acceleration is the rate of change of velocity with respect to time. Then acceleration is a vector quantity just like velocity, and then acceleration has both magnitude and direction. I think this is not new to us all because I've already explained what a vector quantity is. The SI unit of acceleration is just m over s squared. M over s squared. So that's the formula from the definition. So from the definition, you can have this particular formula whereby you have average acceleration is equal to change in velocity minus change in time. Instantaneous velocity, instantaneous acceleration is the same. It's the same definition when it comes to defining the instantaneous velocity. So for the instantaneous acceleration, there is the issue where time is approaching zero. Time is approaching 0. So for this guy, time is simply approaching 0. Okay, and then for this one, you also need to consider that you are playing with the slope of the tangent. You're playing with the slope of the tangent. That's why we have the formula, which is this one. So for you guys, this you will not use it for your first year. Okay, we can move on. Average acceleration is the same thing which I've already explained, is equal to change in velocity over change in time. So Vf minus Vi, so velocity final minus velocity initial over time final minus the time initial. So this is the velocity initial, and this is the velocity final, and then this part is the change in velocity. From this point to that point is the change in velocity. Then time, you have the x component, so the y component is velocity, the x component is time. So you have initial time and the final time. These will be applicable in our calculations. So velocity as a function of time. So velocity as a function of time, I think from this particular formula, you can derive that formula. This is something you did in your high school. So already we have about 5 formulas that you need to take note of. So you just make final velocity the subject of the formula, and that's how you can derive that particular formula. So it is tempting to call a negative acceleration as deceleration, but note that when the sign of the velocity and the acceleration are the same, either positive or negative, then the speed is increasing. So at school, we would have been told deceleration is when the slope is going down. Yeah, quite all right, we can say that, but we need to understand that whether the sign is positive or the sign is negative, then the speed is still increasing. So take note of such a statement. So when the sign of velocity and the acceleration are in the opposite direction, the speed is decreasing. I would love you guys to take note of these two statements for the sake of multiple choice. For the sake of multiple choice, take note of these two statements. When the signs of velocity and acceleration are the same, whether it is positive or negative, then the speed is increasing. This is for the sake of MCQ. When the sign of the velocity and the acceleration are in the opposite direction, then the speed is decreasing. Okay. Now, average acceleration is the slope of the line connecting the initial and final velocity on a velocity time graph. So the slope or the gradient of this particular blue line, that's what we are calling the average acceleration. Average acceleration. Take note of that. Ladies and gentlemen, do we have any question at this particular point so that we can move on? Do we have any question? Any question? Any question? Let's feel free to ask questions. Remember, one thing I can... Yes, Tuabona. Okay. So one thing I can tell you guys is, life is life, and life depends on you. If you're not serious in your life, you never experience change, and that's a fact. If you're just there waiting for your parent to do everything for you, trust me, there will be a point where they cannot help anymore. So you as an individual, put much effort, try, have that thirsty of change, even when the whole world is against you, or the whole world doesn't believe in what you are doing. Just keep on doing it. Me, I'm here, I can teach as much as I can, but if you yourself, you are not putting in an effort, you can't go anywhere. So if I said any question, feel free to ask. This is your life. One day the possibility will not be there. You'll be there enjoying life or not enjoying it, depending on the decision you make. So let's move on. Let's accelerate. So when you talk of instantaneous and uniform acceleration, you need to understand that the limit of the average acceleration as the time interval goes to 0. So time is normally approaching 0, just like in the same way we had the instantaneous velocity. Even in instantaneous acceleration, time is approaching 0. Okay, so you normally use the limits, and this part is just simply saying time is approaching 0. I'm going to explain more about this when we do our part. So when the instantaneous acceleration are always the same, the acceleration will be uniform. When the instantaneous acceleration are always the same, the acceleration will be uniform. The instantaneous acceleration will be equal to the average acceleration. So when you're looking for the value of the instantaneous acceleration, you normally consider the slope. You normally consider the what? The slope of the graph. Then instantaneous acceleration is the slope of the tangent. Okay, I've observed that. Okay, so we can continue. So when we talk of instantaneous acceleration, it's more like the same as the instantaneous velocity. So you need to understand that for instantaneous acceleration, the time is normally approaching what? 0. The time is normally approaching 0. And then this is the formula whereby you are finding the limit where time is approaching 0. Actually, in this case, you are normally going to use dy dx. But for this part, we'll explain more when we use equations and when also we do calculus in mathematics. So when the instantaneous acceleration are always the same, you need to understand that the acceleration will be uniform, and the instantaneous acceleration will be equal to the average acceleration. We'll discuss more when we do the calculations. Then the other thing that you need to understand that the instantaneous calculation is just the slope of the tangent to the curve of the velocity time graph. But in this case, this is not the graph for instantaneous acceleration. I'll show you the graph. It also looks like that of instantaneous velocity. It just look like the same. The only difference is that for instantaneous velocity, you are having the distance, yeah, and not the guy. So like, let me show you, yeah, this one. So when you deal with instantaneous acceleration, this part where there is displacement, it's going to be velocity, and this side where there is time, it's going to be the same time. Yeah, that's for instantaneous acceleration. I did not include it because they are just almost the same with instantaneous velocity. Okay, so we can move on and look at some few graphs that you are supposed to take note of and the relationships that you are supposed to take note of. So of this graph, and in this particular case, I'm going to look at relationship between acceleration and velocity. So this is my first stage. Relationship between acceleration and velocity. Okay, remember acceleration is the change in position with time. Okay, so this graph is for velocity. Ladies and gentlemen, pay attention. This guy is for velocity, then this one is for what? Acceleration. This one is for acceleration. Okay, so I'm trying to relate the relationship between these two guys. So the first thing that you need to understand that velocity and acceleration are in the same direction. Why? Because acceleration depends on velocity. We know that. And both of them are vectors. So velocity and acceleration are in the same direction. 2. Acceleration is uniform. Then velocity is increasing. So if you look at the slope, this rate slope here, if you look at this slope, please, I'm trying to explain these 2 points. Very important. So take note of that. I've said acceleration is uniform, of which blue arrow maintain the same length. Velocity is increasing. Red arrow are getting long. So look, when the acceleration is uniform, the velocity is what? Is maintaining the same length. Like if you look at this point here, this is velocity from here to there. There, the velocity is constant. You have a constant velocity. Since you have a constant velocity, the acceleration is what? Uniform. So this is theory. When the velocity is constant, or constant velocity is equal to uniform acceleration. In short, when the velocity is constant, acceleration is 0. Take note of that. When the velocity is constant, acceleration is 0. Okay? Then, when the velocity is increasing, you need to understand that you are going to have a constant acceleration. I'm repeating that. Uniform acceleration is equal to 0 and is the same as constant velocity. Then constant velocity constant velocity, when the velocity is changing there, you need to understand that you're going to have constant acceleration. So uniform acceleration is the same as constant velocity, and uniform acceleration is equal to 0. Okay, so when the velocity is the same, it's not changing, it's just 2 meters per hour, 2 meters per second, 2 meters per second, 2 meters per second, meaning it's just the same. Like in that case, it's just 4 meters per second for this graph. You look at it, 4 meters per second, 4 meters per second, 4 meters per second, from 3 seconds up to 8 seconds. It's just the same thing. So in such a case, then what we are just trying to analyze is that we have the acceleration, which is 0. From here to there, the acceleration is the acceleration is what? The acceleration is increasing. Okay, so there is an increase in speed. There is a decrease in speed. Okay. So we can move on now. Okay, so positive velocity and positive acceleration. So in such a case, let's say you have a case like this one, whereby distance is not involved but time is there. You can just simply work out using that particular formula. So for this formula, distance is not there. Okay, so that's what I was just simply explaining when you talk of that part. The other part which I can talk of is the relationship between acceleration and velocity, which is the second stage. In this one, uniform velocity, which is shown by the red arrow, maintains the same size. Okay, uniform velocity, it's maintaining the same size, like that one there. Then acceleration equals what? 0. I think these things I've already explained them. The acceleration is equal to what? 0. At that particular point, acceleration is equal to what? 0. And that's the formula. The same things which I've already explained. So these are things that you need to understand. Uniform velocity is equal to constant acceleration. And a constant acceleration, it is an acceleration which is what? Which is 0. But this doesn't mean that the car or an object is not moving. This car is moving, but what's not changing is the velocity. It's just moving at the same pace, enjoying the movement. Okay, so that's the case there. I think that has been explained already. The other relationship, we can say acceleration and velocity are in opposite direction. So when acceleration and velocity are in opposite direction, that simply means that this car is decelerating, right? There is a decrease in speed. So acceleration is uniform, and then the blue arrow is maintained. Then you have the velocity